Hello everyone, myself Ketan Bausa, Assistant Professor in Engineering College Ahmedabad. In today's session, we discuss about communication protocol from chapter number 2, device and communication buses in embedded system. So now, what is communication bus? What is protocol? The first question arises in our mind. And we already know and already heard about this word, the protocol, drivers, communication buses, that we already know and heard in microprocessor and microcontroller subjects. So now we go ahead and we discuss in detail what exactly the protocol is and what exactly the communication protocol is. So now what is protocol? The first question arises in our mind. What is protocol? A protocol is a set of rules and a regulation is called as a protocol. When you're talking about the communication, means what? The exchange of information from one system to the another system with a medium is called a communication, right? So now we combine the protocol and communication. The meaning is that a set of rules and regulations that allow the two electronic devices to connect or exchange the data from one place to the another place or from one IC to the another IC is called as a communication protocol. So basically, first of all, we know what is a protocol, what is a communication. Then we integrate communication protocol and means what we have to transmit the data from one IC to the another IC with some specific rules and regulations. It's called as a communication protocol. So in terms of the electronic circuit, we have to take care about three types of a protocol: parallel protocol, serial protocol, and wireless protocol. What is parallel protocol? The physical layer capable of transferring the multiple bits of data. Means multiple data or multiple type of information is passing from one place to the another place. In terms of serial communication, a physical layer transmits one bit of a data at a time. Means only one bit of information is passed at a time. It's called as a serial communication. In terms of the wireless communication, no physical connection is needed for transforming at a physical layer. Means what? In terms of the parallel communication, the multiple bits or multiple data is transmitted at a time. In terms of the serial communication, only one bit or one data is transmitted at a time. In terms of the wireless communication, there is no physical layer, there is no physical type of any devices or integrated plan is there. Only transmit the data without a physical layer. Now we're talking and discuss about serial communication in depth. What is serial communication protocol? A single data wire is possible. Also control the power wires, word transmit or one bit at a time, higher data through with a long distance, less average capacitance, so more bits per unit of a time. Cheaper is there, less bulk is there because only one bit is transmitted at a time. We can say that, so it is also a safe. More complex interfacing logic and communication protocol. Sender need to decompose the word into the bits. Receiver need to recompose the bit into the words. Definitely, because in terms of the protection point of view, in terms of the security point of view, we have to use the mechanism for understanding the devices. Fine. If they understand, the receiver will understand the sender is proper, then and only then it will receive the data. Otherwise, it will not receive the data. So it provides the security also. Control the signal often send on the same wire as a data, increasing protocol complexity. So definitely it's only one wire protocol, so it also adds some complexity part, but it transmits or receives the one data at a time, so it provides better connectivity as compared to the protocol, as compared to the parallel protocol. Now we're talking about the parallel communication protocol. Now what is parallel communication protocol? Multiple data, control and possibly power wires, one bit per wire. Means multiple data is transmitted at a time. Higher data throughout the short distance. Typically used when connecting devices on the same IC or same circuit. Bus must be kept shorter because of the large bit is transmitted, multiple bits transmitted from one place to the another place. So it is a large distance, so definitely there is a chances of data falling, or we can say that the malfunction. Long parallel wire result in higher capacitance value which require more iron to charge and discharge problem. Data malignment between the wire increasing as length increasing. It's a malfunctioning behavior that I have already told you, and higher cost and also a bulky. Why it is bulky? Because multiple data is transmitted at a time. So this is a disadvantage of parallel communication bus as compared to the serial communication bus. Now we're talking about the wireless communication protocol, which is one of the most popular, and right now we are familiar with this protocol very well as compared to serial and parallel. Like Bluetooth is one of the best example, Wi-Fi is one of the best example, Zigbee is one of the best example of the wireless communication. Now we're talking about the infrared and IR. In terms of the IR, the electronic wave frequency is just below the visible light spectrum. They are using the diodes to transmit the data from source to destination, but it is a limited range. I give you one simple example of IR LED. Like right now, people use Wi-Fi to transmit the data from one place to the another place. RF, radio frequency, it generates a specific type of electromagnetic waves, and that electromagnetic waves is generally used to transmit the data from one place to the another place. Fine. So these are the few protocols which play a main role to transmit the data wirelessly without any physical link. Fine. So this is very popular, and also it is not that level of bulk, or we can say that the complex as a parallel is. And because of that reason, we use a serial and wireless more as compared to the parallel protocol because of the data loss problem, bulky, complex structure. Okay. So I hope that you are getting the idea what exactly serial communication is, what exactly parallel communication is, what exactly wireless communication is. Okay. So now we go and discuss in depth about serial communication, and for the serial communication, one of the most popular serial communication is UART. Means what a UART is. There are a number of serial communication protocol, like there is UART, UART, USART, I2C. There is also other type of protocol like SDI based, SCL based. There are a number of protocols right now in a specific serial communication. Now we're talking about a UART. Universal asynchronous reception and transmission, or we can say that universal asynchronous receiver and transmitter. Now what is UART? UART stands for the universal asynchronous reception and transmission, means universal asynchronous receiver and transmitter. We also call as a receiver and transmitter. Means a simple serial communication protocol that allows the host communication with auxiliary devices. Only one cable is transmitting the data from source to the destination. And UART is also support the bidirectional, means asynchronous and serial data transmission also, means you can provide the connectivity in terms of the bidirectional. It is a two data line. One is a transmitter means TX pin, and another one is a RX, it's a receiver pin, which is used to communicate through a digital pin 0 and digital pin. One of the best example of the TX and RX is your Arduino Uno board. If you see your Arduino Uno board, there is already available the TX pin 0 and RX pin 1 for provide the connectivity between the devices. TX and RX are communicated between the two devices, USB and a computer. If you know, in Arduino board we are connected directly Arduino board to your microcontroller, and when your program is uploaded inside the chip, you can see the LED is blinking at that time, right? And means what the data is communicated, means transmitter and receiver pins are activated at that time, means the data is going on from computer to a microcontroller. So communication is establishment, then and only then the program will be loaded inside a microcontroller. UART can also handle the synchronous management issue between the computer and external serial devices. It can operate on three ways: simplex, half duplex, and full duplex. In terms of the simplex, the data transmission in one direction only, means you have to transmit the data only. In half duplex, the data transmission is either direction but not in simultaneously operation. Transmit but there is no in simultaneously operation. In terms of the full duplex, the data transmission in both directionally and simultaneously, means you can handshake the data simultaneously and a side and a receiver side point of view, means data transmission from transmitter side or receiver side, both way. We use a full duplex basically for data transmitter and receiver at a time. UART, as I already told you, once connected the data flow from TX to RX of the receiver UART. A UART is an asynchronous serial transmission, so there is no clock is required, there is no depend on the clock process because it's asynchronous mechanism. So transmitting the UART, convert the parallel data from the master in terms of the CPU and convert into the UART format. Okay, and it will then convert the serial data into the parallel format, and again you can see inside your computer. So this is the best example of, you can see there are the two devices or two chips from UART 0 and UART 1, or you can see that UART 1 and UART 2. So the transmitter pin is send the data to the receiver pin, or this transmitter pin is transmit or receive the data or transmit the data to UART 1. Means UART 1 is transmit the data to UART 2 and UART 2 is transmit the data to UART 1. So a UART has a no clock. So UART at the start and stop bit when data is being transmitted, because to provide the protection and to provide the security, so data will be transmitted to authenticated receiver only. Fine. So it provides start bit and stop bit mechanism. This helps the receiver UART know when the start reading bit as the bit represent the start and the end of the data package. So when the receive UART detect a start bit, it will read the data as per the baud rate. So it's a standard baud rate 9600. So UART data transmission speed is referred as a baud rate. It's set to 115 by default, means it's too high rate. You can also go with 115 but for the standard, we are using the 9600 rate, right? So it's based on the symbol transmission rate, but it's similar to the bit rate. So both UART must operate it about the same baud rate if the difference of baud rate is more than 10%. So the timing of the bits may be off, and the user must ensure the UART are configured to transmit and receive from the same data package. Fine, so you have to data transmit on the same package rate, only then and only then the accuracy will be possible. So I hope that you are getting the idea about the UART, what exactly UART is. Now we are talking about the I2C protocol. Now what exactly the I2C is? So I2C stands for the Inter-Integrated Circuit, or I2C protocol, or I2C protocol. It is one of the most popular protocol right now is going on in electronic side, because you can see number of sensors right now is based on the I2C protocol. Like RTC is one of the best examples, is that there are the number of sensors which is right now directly linked with the I2C protocol. In our Arduino board, in number A4 and A5 is work as a I2C protocol, means SDA and SCMP. So it is a serial communication protocol similar to the UART, but not use of PC devices communication, but they are used with the modules and sensors. Means you can directly connect with the sensor. There is no need to use PC. So this is one of the best advantage of I2C protocol as compared to the UART protocol. So it is a simple bidirectional or two-wire. As I already told you, it's only SDA and SCM. So synchronous serial bus and require only two wire to transmit the information between devices connected to the buses. They are used to project the required many different parts, like sensors is there, drivers is there, explanation is there. So working together, they can connect it up to 128 devices. So this one is a limitation, or we can say that this one is the advantage of I2C protocol. That means you can connect 128 devices at a time using I2C protocol. So it is an I2C use an address system, and to share the bus, many different devices can be connected using the same wire, and all the data are transmitted on a single wire and have a low pin count. So the trade-off for the simple wiring is that it's slower than a SPR. So speeding of I2C is also depend on the data speed, wire quality, and external noises. If you are connected more number of devices at a time, then definitely you are getting the slow rate. If you are connected less devices at a time, then you are definitely getting a higher rate. So the I2C protocol is also used for the two-wire interfaces to connect the low-speed devices like microcontroller, EEPROM, A2D, D2A converter, IO interface peripherals, and number of devices. So I2Cs play a main role when you want to handshake the data from source to destination. This one is the best example. You can see one is a master and a number of slaves. You can see the three slaves is connected to the master. So SDA means provide the specific addresses, and the SCL provides specific clocks. So based on the address, it will choose a specific type of slave, and according to the specific clock pulses, it will drive the data from one place to the another place. So this one is the best example of I2C that you can understand what exactly I2C is in one particular diagram. In I2C is a communication protocol often used in embedded system as a way to transmit the data between a master and a single slave devices. So it is a bidirectional two-wire serial communication bus, serial clock and serial data wire to send and manage the data between devices and connected buses. So it's a two wires. First wire is SD and second wire is SCA. Now, what exactly similarity and differences between the UART and I2C? Both I2C and UART are similar in their purpose is to transmit the serial data at a low data rate between the devices, and both use two wire interfaces. Like they are using TX and RX, and here they are using SDA and SCA. Both are also commonly used for short and medium distances data transmission only. I2C, however, use a master and slave configuration that use a clock signal to help synchronize the data being read to transmitted by the devices. In terms of UART on the other hand is the hardware that is respond for implement asynchronous serial data system for point-to-point connected and includes there is no clock pulses. So in terms of the I2C we are connected with the clock pulses, or in terms of the UART we are not connected with the clock pulses because of the asynchronous mechanism. Here we are connected with the clock pulses to provide the synchronous communication. So these are the similarity and differences between UART and I2C. So I hope that you are getting the idea of what exactly protocol is, what exactly communication protocol is. We also learn the different types of protocol like serial, parallel and wireless. In serial we learn about UART and I2C, and also we see what exactly the difference and similarity between UART and I2C. So if you have any doubt which is related to communication protocol, then you can feel free to contact me. So thank you for watching.